Hey guys, happy Wednesday. I'm gonna work out the some problems on the ACT packet first today, and then we'll go back over to the Knox County review packet. I'm gonna do number 12 through 18 in this video, and it looks like there's some stuff here that is a lot of areas and different things we haven't really covered yet this year, but some of it should be familiar from middle school whenever you studied area and perimeter and that sort of stuff. Some of it's new, and I'll just give the best explanation that I can, and I'll try to relate it to stuff that we've already studied. So number 12, a rectangular garden has dimensions of 30 by 20. So I'm going to always start, if they give me a word description of a drawing, I'm always going to start by making the drawing. So there's my rectangle with 30 feet by 20 feet. And then they're saying that there's a 2-foot wide walkway all the way around the garden. So basically, you know, you've got an extra 2, 2, 2, and 2. So the way we would solve this, if we're looking just for this area, what you've got to picture is that there's a big rectangle and then there's a small rectangle on the inside. And we're going to take the area of the big rectangle and we're going to subtract away the area of the little rectangle. And that's how we're going to get the area of the walkway. So remember, you get to do an area of a rectangle, you take the length times the width. So I've got to figure out what is the length and width of this big rectangle. So if I take my 30 here and I add on 2 more here and 2 more here, the big rectangle is 34 feet long, and then I'm going to add that same 4 to my width. So my big rectangle is 34 times 24, and my little rectangle is going to be 30 by 20. So I'm going to get out my calculator and just do the math, and I don't have a TI calculator at home, I'm just using my iPhone. So 34 times 24 is 816, and 30 times 20 is 600. So 816 minus 600 is going to give me 216. So that is how I would approach that problem, and I'm just looking for my answer key here. I don't know what I did with it. So number 12B is correct, and the description is outside area minus inside area. So that's exactly what we did. I called it big and little, but you can think of it as outside and inside. In 2 hours, the minute hand of a clock rotates to an angle equal to what? So thinking about a clock and the minute hand, in 2 hours, it's going to go all the way around one time and then all the way around another time. So one full rotation is 360 degrees, and if it's going through 2 full rotations, that's going to be 720 degrees. Number 14, the diameter of a circle, there's the center at P. What are the coordinates of B? So this is actually something that we have studied. And if you think about it, the center is the midpoint of A and B. So if we know one end point and the midpoint, we can figure out what is the other end point. So in the x's, to go from 3 to 7, we went up 4. So we're going to go up 4 more. 7 plus 4, that's going to put us at 11. And then to go from 2 to 5 on the y's, we went up by 3. So I'm going to go up 3 more from 5, and that's going to put me at 8. Number 15. So here it looks like we're talking about a triangle ABC, which I'm going to sketch. And A is 23 degrees, and B is 84 degrees. And then they're asking me what is the longest side. So what I need to figure out is what's the angle measure of angle C, and the reason for that is a rule that the longest side is across from the biggest angle. So right now I think that the 84 is the biggest, but to prove to myself that it is the biggest, I am going to use the fact that all my angles in a triangle add up to be 180. So I'm going to take 180 and subtract 23 and 84 to figure out what is that missing angle. So it looks like that missing angle is 73. So the biggest angle is 84. So the side across from 84 is side AC. That's choice A. And number 16, we've got angle OAB. So they're telling us this angle right here is 45. What's the area of the shaded portion? Now the reason they give us that angle is so we can know that this is an isosceles triangle. How do we know that it's isosceles? Because if I add everything up to 180, I'm going to figure out this missing angle over here is 45 as well. So whenever our base angles are the same, then our legs are the same. And also it's inside of a circle. So this is a radius and this is a radius. The radii are always the same. So our next order of business is to figure out, I'm going to take and find out the area of a whole wedge of the circle. So this portion of the circle is a fourth of the total area. So area of a circle has a formula, and that's pi r squared. So I'm going to take pi times that radius squared. So this is going to give me the area of this whole wedge, and then I'm going to subtract off the area of the triangle. And so the area of a triangle, we have a formula for that too, is 1/2 base times height. So 1/2, the base is 4 radical 2, and the height is 4 radical 2. So we're going to use our calculators to figure out what all this is. So 4 radical 2 squared and 4 radical 2 times 4 radical 2, those are the same things. And when you multiply that out using a calculator, you get 32. So I'm going to do 1/4 times 32 times pi minus half of 32. So 1/4 of 32 is 8. 8 pi minus 16. And then I'm going to pray that this is one of my answers, because I don't want to have to figure out the decimals for that, and it is one of my answers. So that's how we figure that out. Now looking at number 17, this looks like one of the diagrams we've used before. Maybe it'll be something we can figure out. So angle ABC is right here. And what I am seeing is that this 135 is an exterior angle of a triangle. So remember, an exterior angle theorem says the measure of the exterior angle is equal to the sum of the two remote interior angles. So the one we're looking for is the other remote interior. So if I can just subtract this 25 off, I get a 110. And number 18 looks like another ladder leaning against a wall. So let's draw that out. Okay, so I've got a wall, and then I've always got the floor. So all these ladders leaning against the wall problem are really right triangle problems. And here's my ladder. The ladder is always the slanted part or the hypotenuse, and my ladder is 65 feet. Its lower end is 25 feet away from the wall. So they're talking about how far on the floor it is. So that's 25. How much farther away will it be if the upper end is moved down 8 feet? So whatever this height is now, we want to move it down 8 feet. So we're going to go down 8 feet, and then the ladder is just going to slide like that. So here's how I'm going to approach this problem, and then I'll try to think backwards and see if there's another way to explain it. So the Pythagorean theorem is something that we use over and over and over again whenever we have right triangles, and that's the leg squared plus the leg squared is always equal to the hypotenuse squared. So I can figure out what my original height is, because I can say the one leg plus the height squared is equal to the hypotenuse squared. So I'm going to subtract the 25 squared from both sides, and my original height squared, 65 squared, is 4,225 minus 25 squared, which is 625. I get 3,600. And then I'm going to do a square root. So I have to turn my calculator sideways, and there is a square root. So the square root of 3,600. So originally, my height on the wall was 60 feet. So in my new right triangle, after I slide it down 8 feet, now my ladder, that length doesn't change. It stays 65. My new height is 8 feet down the wall, so it's 52. So here's the part that I'm looking for. So I'm going to set up a new Pythagorean theorem. 52 squared plus the floor squared still equals 65 squared. So now I'm going to take 65 squared minus 52 squared, and I get 1,521. And the square root of that is 39. And there we go. Hope this is helpful.